This video goes through sketching reciprocals of trigonometric functions. So let's start with y equals sine theta, and we're going to try and draw y equals 1 over sine theta or cosec theta. So let's start with y equals sine theta. There is my basic graph. You can see that my x-intercepts are at pi, 2 pi, then it'll be 3 pi, 4 pi. So x is n pi, where n's an element of z. My maximum's at pi on 2, also negative 3 pi on 2. So every pi on 2 as I go around, I'm going to get a maximum. So I add 2n pi to that as a general solution. My minimum is at 3 pi on 2 or negative pi on 2. And again, there's a general solution there. So to draw the reciprocal function, the cosecant function, which is y equals 1 over sine theta or cosec theta, we have to remember that sine theta can't equal 0 because I can't divide by 0. So all my x-intercepts are going to become asymptotes. So that's my first step, is we're going to put these asymptotes in. Now the other thing with reciprocal functions is our maximums become minimums and our minimums become maximums. Now these aren't parabolas, they're a little bit flatter. Draw one on your calculator so you can see the shape. You can see I'm trying to make it just a little bit flatter at that turning point. And that's it. So that is y equals cosec theta. Now let's do sec theta. So we'll start with y equals cos theta. And you can see my basic cos graph there. I'm not going to go into that. We've done it before. So when we're drawing y equals 1 over cos theta or sec theta, we start by putting in our asymptotes where our x-intercepts are. And then our maximums become minimums. And our minimums become maximums. Now that graph would continue, so I'm just going to draw it. That's it. So that is y equals sec theta. And you do need to remember these graphs. With time, you will. And at the beginning, you can just derive them so you can draw your translations. So y equals tan theta. Don't do a lot of this in methods. So remembering that y equals tan theta has a period of pi. Because we can't divide by 0, y equals sine theta over cos theta, because that's what our tan is. So we're looking at where cos theta equals 0 because they're going to be my asymptotes. So there's my tan graph there where my asymptotes are at pi on 2, 3 pi on 2, or negative pi on 2 and negative 3 pi on 2. So when I'm drawing my cotangent, or my y equals 1 over tan theta or cot theta, we have to remember that in this case, sine theta can't equal 0 because cot theta is cos theta over sine theta. But again, if we think about our original graph, which I have here in green, my asymptotes go where my x-intercepts are. So start by putting those in. And now they're where sine theta equals 0. So just that connection. My points of inflection are going to be where my asymptotes were. And because it's a reciprocal graph, where we go from low to high, we're now going to go from high to low. Here we go from high to low, so we're going to go low to high. So you can see why it's a reflection of what it was originally. Okay, so that is y equals cot theta.